Kia ora koutou. This is video 2 going through this worksheet from Dr. Austin Maths, which is called Match Up More Complex Factorising. If you want to find the original of the worksheet, you can go to her website, which is here, and there are lots of lovely resources there. So in video 1, what I did is picked out all of the questions out of these 12 that were difference of two squares, and now I've got these 6 questions left to do, which don't fit a difference of two squares pattern. And when you first look at them, they look, I guess, quite daunting compared to what we're used to, because we've got x and y in there, and in these ones we can see that we've got the x and y all mixed up, right? So if we just think about for a moment, if we had 4x squared plus 12x plus 9, hopefully by now that wouldn't look so bad, right? Because what we could do is we could use the grouping method to factorize that one. So I'm going to start by showing you what we would do with one that didn't have the y in there, and then show you that it's actually not that much harder when we've got the weird y here and the y squared here. So the grouping method says that I want two numbers that multiply to give me 36, and I want two numbers that are going to add to give me 12, right? And what I'm doing here with the 36 is pulling it from the 4 times the 9. So we're finding a way to intelligently split up the plus 12x. And both of those numbers are going to be positive. So we've got, what have we got? Let's think, 6 and 6, right? So 6 times 6 is 36, and 6 plus 6 is 12. Sorry, that took longer than it should have. What can I say now? Well, I can write out that 4x squared plus 12x as 4x squared plus 6x plus 6x plus 9. Now we do two-step factorising on each of those. And we get the highest common factor here is 2x into 2x plus 3. And for the second part, the highest common factor is 3 into 2x plus 3. And some of you will have spotted straight away that this is a perfect square, and some of you won't, okay? But eventually, it's good if you can get to the point where you notice that here you've got 2 squared, here you've got 3 squared, and here you've got 2 times 2 times 3. Okay, so I'll take all of that out, and I'll just show you how we can spot that it's a perfect square a bit more quickly. Let's just undo some of the mess. Okay, so going over that again, 4 is 2 squared, 9 is 3 squared, and the middle term is 2 times 2 times 3. So that's why this one, once we get really good at factorising, we can hop straight to that pattern. So if we know that that's the pattern with no y's in it, let's see what happens once we've got the x times the y. Well, now we've lost the y, we need the y back in. Just pop down your brackets. This bit here is easy. This is going to be 2x times 2x in this case. And this bit here, if we try 3y and 3y, we know the sign pattern has to be a plus plus 1. Then here, when I times those together, I get 6xy, and here I get another 6xy. So it really is that easy, okay? If you can think about how to do the grouping part of the problem on the numbers, then the y's just kind of slot in to give you that mixed up term here and the squared term there. All right, let's try a couple more. So the thing to be focusing on is what are the numbers? What are the coefficients going to be? So let's see the next one. 4x squared minus 35xy minus 9y squared. So my pattern is going to have a something x here and a something y here and a something x here and a something y here. So I can work with grouping as usual again. I want two numbers that times to give me 4 times negative 9, negative 36. And I want them to add to give me negative 35. In this case, negative 36 plus 1 will work out nicely. And that's how we can split up the middle term. So just as we did grouping on easier quadratics, we can do it on these mixed up x and y ones. So we split this up into 4x squared minus 36xy plus xy minus 9y squared. And now we can factorise the first bit and factorise the second bit. So here we have 4x into x minus 9y. And for the second part of the factorising, we have plus y into x minus 9y. And that gives me my final answer, 4x plus y times x minus 9y. Okay, 4 left to do. I'd like you to pause the video now and try and work through questions 7, 8, 11 and 12. They're not all that pattern, but the grouping idea should help you quite a lot. Right, question 7, 4x squared minus 6xy minus 4y squared. Well, the first thing to notice is that I have a common factor of 2 in the whole thing. And once I deal with that, I think this is one where probably most of you guys could do this just by guess and check, because this 2x squared has got to come from 2x times x, right? 2 is a prime number, so the only factor pair that's going to work is 2 times 1. And the same thing at the end. I want to end up with a minus 3xy, but that's got to come from some combo of 2 and 1. So let's try putting in a 2 here and a 1 here to get the numbers right first before we think about the y's. Actually, you know, I'm going to go straight to writing a y here. I think you're probably used to that by now. So in here, this is going to give me, if I put a minus in here, that's going to give me minus 4xy, and then a plus in here is going to give me the plus xy. So that one we can do, I think, without doing grouping. You can do that by just spotting it, and that's your final answer there. Now, if you do need to use grouping on it, it would go like this. Something times something has to equal negative 4, and something plus something has to equal negative 3. So the split up there will be negative 4 times positive 1. And you can do your factorising from that point. Okay, so you're going to split the minus 3xy into minus 4xy plus xy if you do it that way. Okay, so if you still feel that you need to use grouping until you get the hang of these, that's what it would look like. All right, let's look at question 8. So question 8 looks awful, but it's actually easier because we have a really clear common factor sitting there. So 2x plus 3y squared plus 2x plus 3y times x minus y. Take out the common factor of 2x plus 3y, and then work on the first term. We get 2x plus 3y plus this one, x minus y, right? Because the common factor here is 2x plus 3y. Now we just have to clean that up, and we get 2x plus 3y times 3x plus 2y. On to question 11, which is a different one again. So I really love these questions because they are so close to each other, and yet there are so many different ideas that we have to link up to be confident with all of these different patterns. So with this one here, 4x to the power of 4 plus 4x squared y plus y squared. So first have a look and see if there's a common factor in the coefficients. There's not, because we don't have anything good here. Next, look for a common factor in the x's. Looks good to start with, and then I've got nothing here, and I've got no y's. So this is one where I'm going to have to use, I'm just going to do this one by guess and check. I can see that this is a square, this is a square, and it's a nice easy plus plus pattern. So let's try 2x times 2x. That's going to, 2x squared times 2x squared, and y here. And we'll see if that works. And look, it does work beautifully, right? Because 2x squared times 2x squared will match up to this. And then we have 2x squared y here, and another 2x squared y here, which matches that middle term. All right, so this is one where you've got a perfect square pattern. You've got a square here and a square here, and so hopefully it's all going to whoosh out at the end. Technical term. Right, what about the last one? Well, I've got 9x cubed plus 9x squared y minus 4xy squared. This time I have got a common factor, and it's an x. And it's hard to see what's going on until we've dealt with that. But if you look at this one, it looks like this is maybe not going to be a perfect square pattern. So let's see how we can do this. So I'm going to do this first with just looking at it and spotting it, and then I'll show you how we can use grouping on it as usual. So when I look at this, I notice that I've got a square number here, a square thing here, and I've got an x, y in here. So I'm going to try writing down 3x here and 3x here. I've got a minus here, so I've got to have a plus minus pattern. But if I try just doing this, plus 2y minus 2y, that's a difference of 2 squares. And the whole point of that is that I'm not going to have a middle term, right? So that doesn't work, because that gives me 9x squared minus 4y squared. But I don't want that, because I need a plus 9xy. So that tells me that it can't be minus 2y and plus 2y. So let's think about other factor pairs of 4y squared. Well, it could be 4y times y. So let's now try arranging that. I'm going to make the little one of those, the y here, and the 4y here. Now we're going to expand and see if it works. Right, well, lost my bracket. Right, so the 3x times the 3x is matching up to give me 9x squared. Next up, I've got plus 12xy, so this is looking good. And now I've got minus 3xy in here. And then I have not a plus, but a minus 4y squared. So we're good, right? That worked fine. And again, you could use grouping if you want to. I'm going to do that quickly now, even though I suspect there's basically no one left watching this video by now. So to do grouping on this, we've got 9 times negative 4 is negative 36. So my two numbers that I'm splitting into have to multiply to negative 36, and they have to add to give me plus 9. And those two numbers are going to be 12 and negative 3. And those numbers will be familiar because that is, of course, what we just had up here. We had a negative 3 here and a 12 here. Right, so this grouping method is if you're desperate and you haven't spotted it by inspection. And then we'd go 9x squared plus 12xy minus 3xy minus 4y squared. Factorize this and factorize this, and we'd get 3x into 3x plus 4y minus y into 3x plus 4y, which then cleans up to give me 3x minus y times 3x plus 4y. So there you go. I think heaps of lovely examples. They don't come up often exactly like this in level 2 algebra, but if you're working in the more difficult problem solving parts in the excellence questions, you often are going to need to use some of these harder factorizing skills if you're doing anything with quadratics. It's either usually this kind of thing or it's discriminant things and looking at the nature of the roots. Thanks for watching. Send me in any email requests for anything else you'd like videoed over the weekend.